So now our next question is question number 4. Prove that y dy by dx plus x is equal to 0 if x is equal to 1 minus t square divided by 1 plus t square and y is equal to 2 into t 1 plus t square. Almost the same question which is we discussed in question number 3. The only change is there is no b and there is no a in this portion, and the extra thing is we not only calculated dy by dx, but we have to form this result or this proof, which is y dy by dx plus x is equal to 0. In the previous question we just calculated dy by dx, but now we have to form this result which is equal to 0. So the main target is just to calculate dy by dx by applying derivative on this parametric equation. Solution: let x is equal to 1 minus t square divided by 1 plus t square. Differentiate with respect to t. So dx by dt is equal to d by dt 1 minus t square divided by 1 plus t square. So applying quotient theorem here, we have 1 plus t square whole square, and in numerator portion 1 plus t square will be as it is and derivative will apply on 1 minus t square, minus 1 minus t square will be as it is and derivative will apply on 1 plus t square. So this one is as it is 1 plus t square and derivative of 1 minus t square. Again derivative will apply on both of these two functions, and derivative of 1 will be 0 due to the constant function, and derivative of minus t square will be minus 2 into t by using our power rule here. Minus 1 minus t square will be as it is and derivative of 1 plus t square, again derivative of 1 will be 0 and t square will be 2 into t, and this denominator will be as it is, which is 1 plus t square whole square. So by simplifying this one, 2t is the common factor from both of these two terms. So we have 2 into t as a common factor, and the portion which is left here 1 and t square by applying this minus, and from here 2t is the common factor, and the remaining portion is minus 1 and minus plus t square. This minus t square plus t square will be cancelled out, and we have 2 into t, minus 1 and minus 1 will become minus 2 divided by 1 plus t square whole square. And finally we have dx by dt, which is minus 4t divided by 1 plus t square whole square. Now we differentiate y with respect to t. So y is equal to 2 into t divided by 1 plus t square. Differentiate with respect to t. Again 2 is the constant term, so we'll come out from derivative, and derivative will apply only on a variable portion, which is t divided by 1 plus t square. So now using our quotient theorem, 1 plus t square whole square will be as it in the denominator, and 1 plus t square will be as it is, derivative will apply on t, minus t will be as it is and derivative will apply on 1 plus t square. So now we have 2 into 1 plus t square, and derivative of t will be 1 minus t as it is and derivative of 1 plus t square. Derivative of 1 will be 0 and derivative of t square will be 2t. Now simplifying this one, 2 into 1 plus t square minus 2t square divided by 1 plus t square whole square, and now 2 into this one will be as it is, and simplifying t square minus 2t square will be minus t square divided by 1 plus t square whole square. So this one is actually our required dy by dt. By using chain rule, we will form dy by dx. So dy by dx is equal to dy by dt, which is this one, and dt by dx. We already calculated dx by dt, so just reciprocal by using chain rule, putting this value dy by dt, which is 2 into 1 minus t square 1 plus t square whole square, which is this one, into and dt by dx, which is reciprocal of dx by dt, which we calculated in previous slide, which is 1 plus t square whole square divided by minus 4t. And this one is cancel out, and the remaining portion is this minus and 2 by dividing 4, which will become 2 into t. This is actually like this. So in the denominator we have 2 into t, and in numerator 1 minus t square, and by applying this minus to this portion will become t square minus 1 divided by 2 into t. This one is our dy by dx. But remember, we have to form our result, which is actually d we have to form y into dy by dx plus x is equal to 0. So taking y dy by dx plus x, and we have to prove that this one is equal to 0. So putting the values of these all things, y was 2 into t 1 plus t square, and dy by dx, which is here t square minus 1 divided by 2 into t, plus the value of x is 1 minus t square divided by 1 plus t square. So putting all the values of y, dy by dx and x, we will get finally t square minus 1, this will be cancelled out, t square minus 1 divided by 1 plus t square, and this one is as it is, 1 minus t square divided by 1 plus t square. So now simplifying by taking LCM, 1 plus t square will be as an LCM we have t square minus 1 plus 1 minus t square, and the terms t square minus t square will be cancelled out, and minus 1 plus 1 will be cancelled out. So in the numerator we have only 0 divided by 1 plus t square, which will become 0, and this is actually our required proof, which was y dy by dx plus x is equal to 0. So hence proved our required result.